Right, the second part of this chapter is about ozone depletion. Ozone depletion is completely separate. You need to keep it separate from global warming. It's very easy, and especially there will be a question on the AP exam about ozone depletion having an effect on global warming. There are some similarities and there are some factors that can link the two, but you have to be very careful. Reduction in ozone in the stratosphere, which remember that helps with UV radiation, and that's beneficial ozone, unlike the ozone in the troposphere, comes from CFCs, chlorofluorocarbons, which will cause, if we have a reduction in ozone, you have a cause or an increase in UV radiation, which would cause an increase in skin cancer. Reduced ozone does not contribute to an increase in temperature, right? This is very important. UV radiation is different than infrared. Alright, I'm just going to put this. Heat, ultraviolet. Okay? And then you can see from 1980 to 1991 this reduction in the amount of stratospheric ozone. Increased skin cancer. Radiation, if we look at the different types of radiation, we have gamma rays, X-rays, ultraviolet, which are higher frequency, which are on this side on this diagram. And then as you go lower, infrared, radiation, and so on. And the visible light here is what we see. So this is what we don't see, this is what we don't see. Same with here, it's just the opposite. Longer waves, radio waves, higher frequency with ultraviolet becomes more intense, and these can be more harmful versus these. Ozone depletion, how it works, you have chlorofluorocarbons here. Ultraviolet light comes in and knocks off chlorine, and that chlorine then interacts with ozone, which is O3. And that breaks off an O from that. Chlorine binds with that oxygen, therefore you have a oxygen molecule that then can come in and bump off the chlorine again, and the chlorine can bump it off. So now you're only stuck with O2, alright? And O2 cannot absorb radiation. You need the O3. So that chlorine messes it up and it cannot get into O3. CFCs, if we look at the production of ozone depleting, I don't know what the S stands for, it has tones down here, but gases, if you look at from 1986 to 2008, what do you notice? Yeah, most of the countries, they have reduced, they have come down because of the notice of that reduction in the ozone layer, increased skin cancer. CFCs, though, are still in production. They can be let out into the atmosphere by aerosols, refrigerants, which are the main ones, but also foam, solvents, and other products. So some example here where it is from aerosols and then refrigerants. Effects of ozone depletion in humans, worse sunburns, more eye cataracts, skin cancer, and immune system suppression. And forests, it reduces crop yields, it reduces seafood supply by reducing phytoplankton. Phytoplankton are really sensitive to UV radiation. So if you have more UV radiation, you have lower phytoplankton. Wildlife, increase eye cataracts in some species, reduce population of surface phytoplankton. They also produce a lot of O2. So you're going to have less photosynthesis because they're plants of the marine system doing photosynthesis. And disrupt food webs because of the reduced phytoplankton, which is the start of the food chain. Alright, air pollution material, increase acid deposition, increase photochemical smog, and degradation of outdoor plants and plastics. CFC is also a greenhouse gas. So it would cause an increase in global warming, but only because the CFC is a greenhouse gas. Ozone depletion has nothing to do with global warming. Hint, hint, wink, wink. Alright, that'll do it for global climate change and ozone depletion.